So basically, these were our 3 potential inflection points, and we didn't know whether or not they were until we tested values from each interval to see if the signs changed in the second derivative from positive to negative or the other way around. And it turns out for this one that all 3 are inflection points. All right, so our inflection points, and again, this was part D. Inflection points occur at x is approximately equal to negative 0.343, x equals 0, and x is approximately equal to 1.093. Now, technically, with an inflection point, the point part indicates that we would want a y value. So if I wanted to know what the y value was that corresponded to this, I would go back and I would plug it into my original f function in order to get that y value. But typically just the x value is all that you would need in order to describe an inflection point. Part E, we've got the intervals of concavity. And in order to write those, I'm going to use the second derivative intervals. I didn't spell that right. Sorry about that. Try again. Interval. I'm going to use my second derivative test, and these signs are going to correspond directly with whether I'm concave up or concave down. So in this first interval, I'm concave down, then I'm concave up, and then down, and then back to up. So you may want to write it like this. Concave down intervals are, and concave up intervals are. So concave down occurred from negative infinity to negative 0.343 and 0 to 1.093. Up was between negative 0.343 and 0 and 1.093 to infinity. All right, so that pretty much covers it all. In most of your examples in your homework, you won't have to do all of this with one function. It'll either ask you to do the first derivative test or the second derivative test or find your absolute extreme values. But I figured I could keep it a little bit more concise by just doing it with all one example. So let me just quickly review what we talked about. You need to be able to perform a first derivative test where you have to find the first derivative, get your critical values, and again, critical values are found from taking your first derivative and setting it equal to 0. We put it on a number line to figure out where it's positive and where it's negative, and then we can figure out intervals of increase, decrease, as well as any changes in increasing and decreasing which result in minimums and maximums. Our second derivative test mirrored that pretty much the same. F prime of x is the second derivative, f double prime is your second derivative. We take that second derivative and we set it equal to 0 to get some critical values to put on a number line. We see where that second derivative is positive and where it's negative. That will correspond to our intervals of concave up or concave down. And any changes in concavity from concave up to down or vice versa would result in an inflection point. So that pretty much describes everything that you need to know from this section.